at now. So annuities, before we explore the formula, what are annuities? So an annuity occurs when instead of investing one lump sum, such as in the case of compound interest, because in those kind of questions we just looked at, a lot of our questions were someone invests $50,000 and then lets compound interest apply. So that's kind of more of a compound interest scenario. But in the case of annuities, we periodically add a set amount of money to an investment. So for example, choosing to save $500 into an account every single week. So it's kind of like a reducing balance loan, except it's the exact opposite. It's kind of like a consistent savings account. So with a reducing balance loan, like you have this chunk, like this lump sum of money that you owe, and then every month, like you're paying off money to kind of pay off your debt. But with an annuity, it's an investment. So you're doing a similar thing. You're paying $500 every month, for example, but that's going into a savings account instead. So like the example I gave here is, for example, it's like saving $500 into an account every single week. So that's what an annuity is. We can also calculate annuities using recursion. We can see our formula here. Again, it makes sense. So it's, let me just pull up our other variables. So an plus 1, so the amount after n periods plus 1 is equal to r, the factor by which it's growing by each period, multiplied by the amount owed after n periods, but instead of minus r, which is indicating us paying off the loan, it's plus D, which is the deposit at the end of the period. So like I said, when we had the reducing balance loan, there was this sum of money, but our goal was to get it to zero because it was a loan. It was a debt that we had to pay off. But when we're talking about annuities, annuities are an investment. So we're actually adding to our investment every week, month, year, however often we're depositing. So our annuity is going to grow over time, and it's going to grow for two reasons. Firstly, because of plus D, because we're depositing frequently at regular intervals into an annuity. And then it's also going to grow because of R, which is the factor by which it's going to grow. So in reducing balance loans or any type of loans, compound interest works against us. Interest grows, and that's really frustrating because then we have to pay it off. It's not a great thing. But when we're talking about investments or annuities, for example, interest is an awesome thing because interest is increasing how much money we have. So interest is like literally being added to their bank account because they've got their money in that account. So that's why an annuity is going to grow, because we're going to get interest paid out on the money that we have in that account. And also we're going to add to that account regularly. And then, yeah, A0, AN, R are all defined the same here as what we've talked about before. So let's look at an example, do a question. So again, let's look at an example of an account with $20,000. But this time, it's not a loan of $20,000. Think of it like $20,000 in a savings account. Here we have an 8% per annum interest rate, and it's compounding quarterly. So that means our R, our growth factor of our investment, is 1 plus I over M, decimal rate of interest, 0.08, divided by number of compounds per year, compounding quarterly, so once a quarter, so 4 times a year, gives us our growth rate of 1.02 per quarter. So it's going to grow by 1.02 every quarter. And D, this person in their annuity, they are going to invest or add to it $5,000 every quarter. So let's use our formula. So A, N plus 1 equals 1.02 AN plus 5,000, where A0 is equal to $20,000. So our starting point isn't 0. Our starting point, we're told, is $20,000. There was already $20,000 sitting in this account before this question started. So when we apply the rule the first time, so after 1 month, we will have interest applied to this amount that was already in the account, $20,000, and that's obviously the interest, the growth factor. Then we also have the plus $5,000. That's this plus D. That's the amount that's being deposited into the annuity every quarter. So you can see that after 1 quarter, or one quarter of the year, our time period, the amount in the annuity is $25,400. So we can see that $5,000 of that growth has come from the deposit. And we can see that $400 of that growth has come from the interest. And if we apply the formula again to get A2, we'll see that we have $30,908, and then A3, so after a third quarter, and then A4 after a fourth quarter. So that means in this annuity, we'd have $42,256.68 after 1 year, because we started with $20,000, and then each quarter we added another $5,000. So adding $5,000 4 times throughout a year, we add $5,000, then we'll have $10,000 added, then we'll have $15,000 added, and then we'll have $20,000 added. Shows us how we get this final value. So we started with $20,000, we added $20,000 over the course of a year, and then that means $2,256.68 is a result of interest. So they've actually earned like over $2,200 in interest, which is awesome news for this person. So you can kind of see how an annuity is like the exact opposite of a reducing balance loan.